Can everybody hear me okay? Thanks for coming. She gave me a nice introduction, so I don't think more is required. Let's see. This was the last slide that was up there. Could anybody reset to the first? Yeah. So I'm here to talk about AI, AR, and VR. And these are some of the most loaded terms that you can find today. So just a fair warning that I'm going to be simplifying a lot of really complicated things. But my hope is that you'll at least come away with some insight into how these different things are really tightly interwoven. And they're so connected that it's often hard to tell which is which, or even that one of them is in there at all. So that's what I'm going to tackle here. And to tell you a little bit more about what we're doing now, we are Altin. We've been in the VR space for about 7 years now, working with leading platform holders in the space like Facebook, Oculus, and the others. And our focus is to give you an experience of being in a reality. That's a key focus. We're not trying to make games or something. We're trying to give you an experience of being in another world. And we do that by focusing on physical presence analysis, or analysis of the way you move and behave inside the world, so that the world and characters and everything else can react to you in the way that you would expect reality would. And just from that key area, you should be able to get a sense that, yeah, when you're there, when you're moving and behaving naturally, you need AI to interpret that behavior, just like we are intelligent and interpret each other's presence when we're there. That's a key fundamental change in the way that computing works. That's the default mode of interaction for these mediums. Now, continuing on, what is it? What is VR and AR? Let's start there, get that out of the way. And even the greatest experts in the field disagree on what some of these terms mean. And we're probably going to be there for a few years, figuring out what it is and getting a mutual understanding of what and how it works. But I'm going to try my best. And in my mind, these are two separate ends of the same spectrum. On one hand, you have VR, where you take a physical person from our reality and transport it into a virtual environment, fully virtualized, where we can interact and move and behave in the way we do in the real world. So we physically take steps, our body is there, we can pick up items and throw them, fully virtualized objects. And on the other hand, we have augmented reality, which takes virtual things and places them in our physical reality. So these are essentially the same things on a theoretical level. It's us interacting either in a fully virtualized environment or partly virtualized environment. And augmented reality and virtual reality are the same, but they have very different applications. The potential of AR lies a lot in adding software features to reality to help us in our daily lives. Virtual reality, on the other hand, has great potential in training, in entertainment, where we are put in a world that we could never experience in real life. So those two are connected through natural interaction. That's the key here. And natural interaction with or using these mediums is going to continue evolving for decades. We're at a point that is similar to when personal computing and graphical user interfaces were coming along. The hardware involved will continue to add things like eye tracking and speech recognition, all in the favor of making computing more accessible to broader audiences. Anyone can step into a world and start using their hands. If it's that natural, we can make software as intuitive as picking up a cup and drinking water. That's the potential of both of these mediums. natural interaction. Just like when the mouse came along, that is what made computing accessible, natural interaction. Understanding how to use things without having to learn a whole textbook of how computers worked. Same with mobile phones, when touchscreens came along. They made computing more accessible and more natural. And this is exactly the same thing that AR and VR are doing. It's the natural next step in computing. It's going to take a while for all the different parts to emerge and evolve. And that's part of what makes it so exciting. It's the culmination of decades worth of work in computing overall. Now, to name an example of how things change once you start designing software in this way, Walls of the Wizard is our latest experience, and our focus there was to make the world work in the way that reality does. So that involved simulation of things like smoke coming from a cauldron is interactive. Everything has a different sound source, and the sounds change depending on how they are hit together or what materials are involved. There's a specification of weight for every single item. And actual movement of objects involves simulation of physical forces, so that for ultimate realism in how things work. That's the sort of starting point for our VR experience. That's a fundamental change from how something on a monitor works. We have literally been hitting up against a barrier when it comes to making things more interactive and characters more intelligent in conventional games, because we have no commercial reason to. We are not there, so why make a virtual character more realistic? It's never going to get realistic because we're not in there with them. We can't make the behaviors that are convincing and realistic when we are not there. So that's the fundamental change there. These characters, for example, in Waltz, are observing the way you move and behave. If you lie down physically on the floor, they have a reaction to that. If you keep lying down, they have a different reaction than if you stand up again. These types of acknowledgments of your physical presence is what makes characters feel alive in VR. And the more they understand your natural behavior and are able to react like a human, the more powerful the experience. This type of data is really messy. We're no longer pressing A to jump. We're actually physically jumping. And that involves so much data that's inherently messy, like positions and our voices, and all of those things require more AI to understand. And again, the types of experiences, like the commercial experiences, the gaming involved, that's a commercial driver to build more complex simulations and more complex AI. Especially when it comes to natural interfaces. It's not just about characters, it's about being able to put on your AR glasses, walk down a street and point at things and say, what's that? Or is it gonna rain when you see dark clouds and you see weather forecasts overlaid on the clouds? Those are the types of things that we can't do without more AI. This is just one example of, I mentioned earlier, physical forces being simulated. I'm holding a sword that's compelled by physical forces. The character has avoidance behaviors. Just to emphasize again how much of new things are involved. Spatialization of audio and the whole simulation range. So on top of this, the devices involved need to understand reality, like AR glasses. They need computer vision to scan our environments to understand, am I holding an apple or a ball? Am I pointing at a cloud or fog in the distance? They need to understand our environment both on the high level, as in what is an object, but also in terms of how am I moving in physical space. Today, cameras and optical computer vision are the standard for tracking your movements when you're in VR or AR. Environmental simulations will continue to be pushed, and different types of natural interaction, like adding eye tracking to understand where you're looking so you don't have to point. And again, when we have all of these worlds that are accurately simulated and the machine understands it, we can start doing things like training robots in virtual environments, because they are now approximating our reality to a degree where it's essentially the same for many different applications. So all of this holds hand in hand, all of these paradigms that we've come up with for touchscreens and everything else. It holds hands and goes towards a direction which Arthur C. Clarke so appropriately described, that once it gets to this point where we are able to interact with computers as naturally as we interact with the real world, it feels like magic. And we will be able to do things that humans have never been capable of, and bring all of the utility of our mobile devices and computers directly into the real world in a way that just makes it an ambient part of our reality. That is going to signify a massive change in the way we use computers. And it is inevitable that we will evolve in that direction, because natural computing brings power and empowers us. And I think to end this, I'll show you a video we released last week where we are using optical computer-based vision on your hands to literally bring them into a virtual world and show you just how magical these interfaces can get. And before that, we never wanted the hardware. We wanted what the hardware can do for us. That has always been the case. We don't really want the mobile phone, a brick in our pocket. We want what it does, and we suffer it in our pocket because of it. So when we get glasses, or whatever form that will take, that remove that object, we'll want that. So in that sense, the final platform is not a computer, it's getting rid of it. And if you have a chance to play the final video, that would be great. Thanks.